30%. I think that's a big number, which we cannot imagine here in Korea at all. And those opportunities you presented, we believe that they are very promising. And here we see a lot of potential collaboration opportunities. Here in Korea, unfortunately today, we have about 7,000, more than 7,000 COVID-19 cases. It's the worst in our history. Therefore, it has been very difficult for us to attend in the site right now here in Korea. However, there are many Korean large companies attending this session. Many of them, including SK Group, SK Energy, SK Eco Plant, and also Korea West Power Company, and POSCO Energy, POSCO, the engineering and construction. And we also have a Co-Gas Tech, which is the technology company of the co-gas. We have a Korean Petrol Organization. We have Korea Battery Industry Association, the Overseas Resources Development Association, Korea Energy Economics Institute, and also we have a Korea Midland Power, KPMG, Korea Mine and Mineral Resources Corporation, Gyeongdong Energy Corporation, and also Ministry of Trade, Industry and Energy. We have the executive here, and also we have IDEA, and also Energy Future Forum, which is the hosting organization for the session. The session has been very impressive for us. I think it's the first session only, but we see that future business opportunities for Korean companies would like to pursue in the future. It is my pleasure to have the second part of the session, session 2. From Korea, we will have 2 presentations. The first one will be hydrogen energy opportunity in Laos. And the presentation will be made Doosan Fuel Cell, which is probably one of the best, the new energy company here in Korea. And Mr. Hoon-Sup Song will make the presentation. Please enjoy the session.
Hi, good afternoon. This is Hoon-Sup Song, and I'm working for Doosan Fuel Cell in Business Strategy team. I will proceed the presentation on Korea-Laos cooperation plan to utilize the hydropower resources. Laos is the country with the most hydropower resources in Southeast Asia. Laos is endowed with the potential hydroelectric power resources centered on Mekong River. Laos is a country where more than 20% of GDP comes from electricity export, but electricity is overproduced in the rainy season and insufficient in dry seasons. Accordingly, Doosan proposed 2 solutions. First, the first plan is to produce and sell green hydrogen using hydroelectric power, which has a lot of potential. The green hydrogen produced is converted into ammonia and transported to Vietnam Vong Yang port using the newly established Vietnam Vong Yang Industrial Railway. The transported ammonia is exported from the port to Europe or Asia, where demand for hydrogen or ammonia is abundant. The second is to produce green hydrogen, store it as an ammonia for a long time, and convert it back to electricity. In the rainy season, when surplus electricity is generated, green hydrogen is produced and stored as ammonia, and in dry season, it is used as a fuel for ammonia SOFC and ammonia coal-fired power plants, or cracked it again to produce electricity from the fuel cell or hydrogen gas turbine. The electricity produced replace the imported electricity during the dry season, or it or is exported in reverse. The slide you see now is a detailed schematic of the solution proposed by Doosan. First, green hydrogen is produced by using excessive electricity during the rainy season. The hydrogen produced is converted into ammonia suitable for long-term storage and long-distance transportations. The converted ammonia is transported to the port of Pyongyang using new Pyongyang Industrial Railway. Using Pyongyang port, we exported countries with high ammonia demand, such as Europe or Asia. By utilizing excessive electricity, you can create additional business opportunities and become a green hydrogen or ammonia exporting countries. This slide is a second solution schematic. It is same until the ammonia synthesis, but after ammonia synthesis in the rainy season, it is stored in a large capacity tank until the dry season. The stored ammonia is used as a fuel directly in a fuel cell or converted back to hydrogen and used as a fuel in a 100% hydrogen fuel cell or hydrogen hybrid gas engine. The generated electricity can be used in two ways. In Laos, where electricity is currently imported and using the dry season, self-consumption, or in the case of excessive electricity consumed, may be exported in reverse. As electricity infrastructure with neighboring country has already been established, export is possible without additional facilities. Some of you may have questions about why storage or transportation in forms of ammonia, not hydrogen. Ammonia is currently the most popular hydrogen carrier. The currently emerging hydrogen storage or transport method can be broadly classified into 4 categories: high pressure hydrogen, liquid hydrogen, ammonia, and LOHC, liquid organic hydrogen carrier. High pressure hydrogen has a large volume area, so it is expected to be mainly used for short-term land transportation. For long-term storage or transportation, including overseas export, liquid hydrogen ammonia, LOHC, with high energy density is mainly discussed. As shown in table, ammonia and liquid hydrogen have high energy densities, making them suitable for long-distance transportations. However, in case of liquid hydrogen, the temperature to maintain the liquid state is very low, and the technology is not in the commercialization stage. In particular, as an infrastructure for transporting liquid hydrogen has not been established, a lot of development and investment are needed in the near future. On the other hand, ammonia is superior to liquid hydrogen in terms of required temperature, and the infrastructure for distributing ammonia is already established in each country. In addition, ammonia is used as an industrial raw material in a wide variety of the field, even without conversion to hydrogen. So the possibility of importation is very high, even where there is no separate conversion equipment. The global demand for green hydrogen or green ammonia is constantly increasing. COP26 held recently, EU's Fit for 55 initiative and industry RE100 and IMO regulation are key drivers to boost the demand for green hydrogen and green ammonia. In case of COP26, more than 100 countries has already agreed to 30% reduction in methane emission, particularly in United States and China for climate change. Fit for 55 is a more specific initiative in a way of realizations. Fit for 55 is the EU's plan to reduce the net greenhouse gas emission by 55% compared to 1990 by 2030. And the main goal is to introduce carbon border tax. The carbon border tax is based on the production of products within the EU in steel, cement, fertilizer, ammonium, electric power industry, and is a system on the excessive if more carbon is emitted during the production of the products in other countries. RE100 is an industry initiative with the goal of achieving decarbonization of business with carbon-free power sources, including renewable energy. IMO regulation aims to reduce ship greenhouse gas emission by 50% by 2050. These initiatives are intended to lead a gradual transition from carbon-based energy resources to low carbon and ultimately carbon-free energy sources. However, transition to low carbon or carbon-free technology is essential to achieve the goal of agreement among countries as described. Currently, carbon-based energy sources will gradually be converted to blue hydrogen or ammonia, to which carbon capture technology is applied. And finally, to green hydrogen or ammonia based on water electrolysis. Korea is the first mover of Korea-related hydrogen-related policies that have already announced the hydrogen economic roadmap in 2019 ahead of the EU and others. Then in 2021, the world's first hydrogen law was enacted to legislate the hydrogen industry-related promotion policy. To achieve the roadmap, we established the Hydrogen Economic Committee chaired by Prime Minister and designated 3 major hydrogen economic institutions. Korea plans to increase its current annual hydrogen use of 220K tons to about 27 million tons by 2050. However, due to lack of renewable energy resources in Korea, we plan to introduce domestic production as well. The Korean government has adopted ammonia as an energy carrier to introduce hydrogen in the short to midterm. Ammonia imported from abroad is converted into hydrogen or directly used in Korea in the form of ammonia. Application can be broadly divided into industry and power generation. In the case of power generation, it is used for co-firing in thermal power generation or directly injecting or co-firing into hydrogen fuel cell or ammonia fuel cells or hydrogen turbine. In the industrial world, the fuel conversion is scheduled to take a place on high emission industries such as steel, petrochemicals, and cement. Korea, where an increase in hydrogen demand is legally guaranteed, the Korean needs a partnership with the country which in surface renewable energy resources such as Laos. This slide shows the current status of hydroelectric power generation in Laos. As of 2019, about 8 gigawatts of hydroelectric power generation facilities are in operation in Laos, which account for 80% of total power facilities. This figure is the potential of renewable energy power resources, which is directly related to the green hydrogen or ammonia productions. This slide is a schematic summary of the solution proposed by Doosan. You can see the area where Laos and Korea or Doosan can cooperate. First, production. Doosan Heavy Industry has experience in hydropower plant construction and is already participating in the construction of hydropower plant in Laos. Doosan Fuel Cell is currently developing a PEM water electrolysis facility as a national project in Korea. Second, storage or transport. Doosan Heavy Industry has experience in building LNG tanks similar to ammonia tanks in Samcheok, Korea. Third, uses. Doosan Fuel Cell has experience in supplying the world's largest 100% hydrogen power plant, and this plant is successfully operating. In addition, SOFC that directly utilizes ammonia as a fuel is under development as well. Doosan Heavy Industry is developing a hydrogen hybrid gas turbine. Last, export. Korea has adopted ammonia as an energy carrier for hydrogen introduction, and the Green Fund is being created for these purposes. From now, I will explain the core cooperation area with Doosan Fuel Cell. First, it is a PEM water electrolysis facility. Doosan is currently carrying out national project to develop PEM water electrolysis technology together with Korean government. And Doosan Fuel Cell is in charge of technology development for 1 megawatt PEM water electrolysis facilities. This project aims to produce green hydrogen abroad. So we plan to complete concept and basic design in 2021 and start the demonstration prototypes from 2023. The second is hydrogen fuel cell. As one of the world's 3 largest fuel cell companies for power generation and #1 fuel cell company in Korea, we have recorded good results. So product you see in the slide is our flagship model, Pure Cell Model 400. It uses natural gas or LPG or hydrogen as a fuel to produce electricity and heat, and total efficiency including heat reaches up to 90%. It is most commercialized product among the technologies that generate electricity using only hydrogen, and is the optimal solution for storing Laos renewable energy resources and converting them back to electricity. After the completion of fuel cell manufacturing facility in Iksan in Korea in 2017, we entered the market and achieved the #1 in domestic order for last 3 years. Korea is the largest market according around for 43% of global supply of fuel cell for power generation. We are a leading company that installed 344 megawatts, which is more than half of Korea's total supply of around 659 megawatts. The project shown on the right side is the Daesan plant in Korea, completed in 2020. And this project is a fuel cell plant that generates power with 100% hydrogen. Byproduct hydrogen generated from the petrochemical process is used as a fuel, and it is being operated successfully with high efficiency and utilization. The last one is the direct ammonia SOFC. Doosan is currently developing ammonia SOFC for ship and SOFC for land use in advanced accordance with IMO regulation. As you can see, the internal combustion engine currently used in the ship has been a downward trend since from 2025, and alternative approach technologies such as SOFC are expected to take place. Future ammonia carriers are likely to utilize SOFC as a propulsion engine as well. It can be seen as a very suitable solution for Doosan's proposal in that not only ammonia carrier, but also the stored ammonia can be directly injected into SOFC without conversion process. this conclude the presentation of Doosan Fuel Cell. So if you have any question, just let us know. And thank you for your time to listen to this presentation. Thank you so much.
Sorry for the intervention. Should we have the question for the presenter, or we wait till at the end?
Let's make a suggestion that why don't we defer the question to the end of the session? And then I think that we have a little bit of a technical issue here. So why don't we record all the questions, ask those questions to the presenters. Then in Kutra will make sure that
You can ask.
Okay, sorry for the intervention again. So I think this topic is really important for Lao PDR right now. And again, I think this is in the energy transition of the world. We need to understand more of the hydrogen's production or procedure, or even if we are going to do it in Laos. I mean, the key words here, I think if we are using the excess power in the raining season, I think is quite doable, because the tariff rate is quite low comparing to the dry season. But I think well, for my side, for the Department of Corporation and Planning, I think we think that for the concrete cooperation in the future, I think we need some study, or even we should have like a MOU, to do the feasibility study. Of course, the tariff rate during the rainy season will reflect to the investment cost of the hydrogen. Therefore, we should have some kind of mechanism, to do further cooperation in the future. I think my colleague here again, we have the colleague from the Research Institute of Hydropower and Mining. Maybe they have some question to ask, and of course we have another institute for the promotion of renewable energy. Maybe they should have the question to you. As I mentioned, this is very important, and this is very informative presentation. Maybe we should have some kind of another, the opportunity to look at in the more detail for the technical terms. I will ask my colleague if they have some question on the hydrogen. Thank you.
Very good. Thank you very much. We understand your issue. During the wet season, you have excess electricity, and dry season, actually, your lack of electricity, and you need sort of saving medium of the electricity for the time being. And we also believe that hydrogen might be one possibility. I think that your question is very valid. And if you contact Kotra and Energy Future Forum of Korea, we'll follow up and we'll connect you to the right sources in Korea, so you'll be able to get answers for your questions. And we actually have also about more than 10 requests and questions here in Korea. We'll also pass those questions and requests through Kotra in Laos. And we hope that you will follow up those questions and requests. And we'll make sure that there will be a lot of communication after the session. Thank you. After the first session, first speech in the second session of Korea, now let's move to the second speech. The second speech will be made by Korea West Power, and the subject will be power projects in Laos. and Mr. Chang-Seok Lee of Korea West Power will make the presentation. Please give him the applause. Thank you. 박수 한번 주시죠.
Good afternoon, ladies and gentlemen, Korea side and Laos side. Please allow me to wear the mask during my presentation. My name is Chang-Seok Lee, and I'm working in Laos to develop new power project. I'm very glad to have the opportunity to present the power project invested in developing in Laos. Now I'm going to introduce today's presentation as you see contents. First, company overview. Second, power project in Laos. Company overview. As you may know, the KOEPO spun off from KEPCO in 2001 due to the Korea government policy, including 5 other generation company as well. As you see the ownership structure, KOEPO is a public enterprise. Total generation capacity is 11,443 megawatt, which account for 8.9% of total installed capacity in Korea. And our total asset is $9 billion and operating income is $64 million in 2020. And the credit rating is same as Korean government. Our high credit rating is very favorable to procure loan from lenders. Power plants under operation. We have 5 power complex and renewable energy installed over the country. Among 5 power complex, the Pyeongtaek LNG power complex was changed fuel from bunker sea oil to LNG in 2020. This transition is to reduce carbon and follow energy trend over the world. Power plant under construction. The Gimpo combined heat and power plant capacity is 495 megawatt and 281 gigacalorie per hour. The project location is in Hagun Industrial Zone 2, the Gimpo city. This project will be completed by July 2023. Overseas business. We have many projects under operation and development with various energy sources in USA, Europe, East, Southern Asia, Middle East Asia, and Australia. Now I'm going to introduce power project in Laos. The first Sepian Sanamnoi 410 megawatt hydroelectric power project. The project is located in Champasak and Attap province in southern part of Laos. The construction period is 73 months and operation period is 27 years after COD. And total project cost is $1.02 billion. And project structure. The shareholders are SK Ecoplant with 26% of shares, KOEPO and Racha Group with each 25% of shares, and LHSE with 24% of shares. And we have two off-takers. One is EDL for domestic. The other is EGAT in Thailand. Project progress. Signed the MOU with the government of Laos on August 2006 and established project company on the name of PMPC on March 2012. And signed the power purchase agreement with EGAT on February 2013 and groundbreaking on November 2013. And completion of the construction and commercial operation date is 6 December 2019. And this is a plan map of dam and powerhouse and reservoir. As you see, the purple color, the Remark Weir and Sepian Dam and Sanam Dam and 5 saddle dams. And total water volume of Sanam reservoir is about 1 billion ton at the full supply level. And catchment area is larger than Seoul or Singapore. And the reservoir is on Molabem Plateau. Transmission line. In terms of the domestic transmission line, the distance from powerhouse to Sapatong substation is 7 kilometers with 115 kilovoltage. And in terms of export transmission line, from powerhouse to Pakse substation is 113 kilometers with 230 kilovoltage. And from Pakse substation to the Lao-Thai border, distance is 54 kilometers with 500 kilovoltage. In the future, the other IPP power plant, if other IPP power plant connect to the Pakse substation to share the transmission line to export Thailand, then our project company will get the willing charge from the IPP as an additional revenue. This is a cross-section of project and specification of the facilities. The left side, the water in the Remark will flow to the water to Sepian reservoir through the conduit, and the water in Sepian reservoir flow to Sanam reservoir through the closed conduit. And then finally, the water in Sanam reservoir flow to the powerhouse to generate the electricity. This is Remark Weir. We impound water from the Remark River, and then, as I explained, we use the conduit to flow water to the Sepian reservoir. And this is Sepian Dam. This is Sanam Dam. The full supply level is 788.5 meters, and minimum operation level is 760 meters. This is a power intake in Sanam reservoir. This is a powerhouse. The discharge water from powerhouse flow to Sekong River through this tailless channel, and we also supply the water to rice field using the irrigation channel. And operation camp. We have sports facility such as football mini court and indoor court and tennis court, the screen court, and gym to provide welfare to local staff. This is power purchase agreement with EGAT and EDL. In terms of tariff structure of the EGAT, there are three categories: primary energy, and secondary energy, and excess energy. The secondary energy tariff is 60% of primary energy tariff, and excess energy tariff is 55% of primary energy. So PMPC make the revenue $131 billion every year. Subcontractor. QEPO established subsidiary which named QEPO Lao International Company to provide O&M service for 27 years. Our O&M contract is renewed every 6 years. This is a second project under development, Pnoi 728 megawatt hydroelectric power project. Project is located in Champasak province in southern part of Laos. And project owner is Siwa from Thailand. Construction period is 7 years and operation period is 27 years after COD. Project structure. Shareholders is Siwa with 26% of shares and QEPO 25% of shares. The remaining are Kind and EPC company. They also the off-taker. One is EDL for domestic, which we supply 10% of the generating electricity. The other is EGAT for the export, which we supply 9% of generating electricity. Project progress. This project is started since signing MOU between Siwa and Government of Laos on April 2008. And QEPO is involved in this project from signing MOU on September 2016. And feasibility study was approved on February 2020. And environment social impact assessment for procedure of Mekong River Committee was submitted to Government of Laos on October 2020. For your reference, all projects located in main Mekong River or tributary of Mekong River should procedure of Mekong River Committee, which is called PMPCA. This procedure takes 6 months. And Korea Consortium started conducting value engineering to optimize the total project cost and design on August 2021. Dam site is 18 kilometers downstream from Pakse City. And powerhouse site is 600 kilometers from Vientiane capital and 92 kilometers from Sepian Saram Noi hydropower plant. Aerial view of project structure. As you see, the main dam is RCC type, and on right powerhouse, there would be 12 units of turbine and generator. And on left powerhouse, there would be 20 units of powerhouse. And both sides of the river, there would be put fishway for fishes to go away downstream. Major specification. The total catchment area, 545,220 square kilometers. And turbine runner type is bulb tubular. Rated head is 6 meters, and plant factor is 56%. And transmission line will be connected to existing box substation with 230 kilovoltage, and distance is only 5.2 kilometers. And future plan: signing JDA among sponsors on first quarter 2022, and finish MRC PMPCA on first quarter 2022. And project financing closing and groundbreaking on third quarter 2023. This is third project under development, Bualapa 400 megawatt wind farm. The project is located in Kamwan province in the middle part of Laos, and project owner is Pongsatabi Group. Project type is BOO. And operation period is 25 years after COD. And project structure: shareholders is Pongsatabi Group with 75% of share, Quepo 20 to 25% of share, and third investor. And off-taker is EVN in Vietnam. Project progress: this project is started since signing MOU between Pongsatabi Group and Government of Laos 2015, and signed tariff MOU with EVN on June 2020. And Quepo started the feasibility study with Korea renowned engineering company, law firm, and financial advisor, and signed MOU with Pongsatabi Group on September this year. This document is MOU between Pongsatabi Group and Ministry of Planning and Investment. Pongsatabi Group submitted this interim feasibility study to Ministry of Energy and Mines, and got approval from the Ministry of Energy and Mines on December 2019. This is tariff MOU. Project listed in this MOU should be completed by 2025 in order to get tariff the 6.95 cents per kilowatt hour. Project site is 470 kilometers from Vientiane capital. And transmission line from Bualapa substation to the border of Laos is about 16 kilometers, which will be constructed by project company. And the Vietnam side, from existing Hatting substation to the border of Vietnam, is about 74 kilometers, which will be constructed by EVN. Major specification. The data was collected for 41 months, and average wind speed is 7.6 meters per sec. And plant factor is 39.1%. The financial analysis. Assuming that Quepo invests 25% of share, then the revenue per year is $22.83 million US. And dividends per year are $10.23 million US. And we expect that the equity IRR would be 17.8%, and payback period is less than 4 years. Future plan. Approval ESIA by Ministry of Natural Resources and Environment on second quarter 2022. And signing PPA with the EBN and concession agreement with Government of Laos by first quarter 2022. And project financing closing and groundbreaking on first quarter 2023. I'm done with my presentation. Thank you for listening.
Thank you very much, Mr. Chang-Sok Lee. Thank you very much for your impressive presentation. It has been very educative for us. Now, unfortunately, we are running out of time here that we have to move to closing remarks. First, I'd like to ask Honorable Dr. Akomdat Bongsai to make the closing remark for us. Would you please, Dr. Bongsai?
Yes, I would like to give the authorized handover podium control to Dr. Akomdat Bongsai for his closing remarks.
Thank you very much. Thanks for the inviting for the closing remark. Well, it's been honor, and we thanks for the sponsor, for the arranger, that this forum has been established, and we has been exchanged a lot of information, and I think we need to do more for the further cooperation. So again, I would like to thanks for the all speaker for the excellent thought-provoking talks, all participants, as well as Energy Future Forum and COTRA for well arrangement of this forum. Special thanks to the Korean investor for the interest in the potential energy and mining project in Lao PDR. Once again, on behalf of the Ministry of Energy and Mines, Lao PDR, I would like to send best wishes for the coming new year 2022 to all delegation, and wishing you all the good health and success. Stay safe from the COVID-19 pandemic. Thank you.
Thank you very much. We have a surprise guest here, and I would like to ask closing remark for us to PhD Dong-woo Yang. He's the Director of Mineral Resources Division of Ministry of Trade, Industry and Energy in Korea. Mr. Yang, would you please?
Hello, everyone. This is Dong Yang. Thanks for the wonderful forum to strengthen the cooperation between Laos and Korea energy industry. I enjoyed the session really and learned many things about the energy sector of Laos. So I will make effort to support the further development. Thank you.
Thank you very much, Mr. Yang. And on the behalf of Korea, I will make a very short closing remark here. First, I'd like to appreciate everyone's effort for this event, especially the Ministry of Energy and Mining of Laos has been just wonderful. I'd like to appreciate Honorable Dr. Akomdat Bongsai. Also appreciate presentations by respectable Rita Nuruk Raspo and also Mr. Geopashu Ketumala, Mr. Sonesai Sengmani, and Mr. Sulisari Sayasan, and Mr. Paul Hare. And also I appreciate the presentation by Korean speakers, Kun Sop-sung of Dusan Fuel Cell, and also Chang-Sok Lee of Korea West Power. In Korea, there are many energy companies. They are looking for growth and overseas investments. And they like to be sincere partners for foreign businesses. And we'd like to share some of our success stories and some of the technologies that we have. But we believe that Laos has a great potential, and always, if you build power infrastructure first, there will be a lot of industries will come. That's what we believe, and we'd like to work with you and to be a great partner. So again, thank you very much for everyone, and thank you very much for the support of KOTRA, and we are very glad. And also, as I said, we'll make sure to follow up the request from Laos and also from Korea, and we will continue the communication. Thank you very much.
Thank you, Mr. Hee Jip Kin, and also thank you to all Korean sides and Dusan Fusil and Kowepo for the presentation. We sincerely apologize for the short question and answer part. But if you have any questions to ask the Korean companies, please contact KOTRA Vientiane. Before we end the quorum, we have to, once again, may I kindly ask all guests to come on the stage for a memorable group photo, because some guests were not here at the beginning.
Okay, one more. 1, 2, 3. Cheese, Pepsi. Okay, thank you so much for your time. Thank you.
Thank you, everyone. Please be informed that our small gifts are prepared in the exit desk. Before you leave, please take it as a gift from KOTRA.